Hello again, children. I have another problem for us to study. This is the same problem we have studied in class. In this case, we're still using our conceptual understanding to divide fluently, and I'll show you an example of that. I'm also teaching you more division strategies if you don't have them already. A lot of us do have a strategy. Sometimes just we have difficulty applying the strategy when we have a number that's smaller and we're dividing it by a number that's larger. This is a problem much like the previous one in which the dividend is smaller than the divisor. Divide 6 3/4 feet of yarn by 18 so that 18 people all get the same length. It would be easy if the yarn was 18 feet and you had to split it amongst 6 people, or if the yarn was 18 3/4 and you had to split it amongst 6 people. But in this case, like the previous problem, we have yarn that is 6 3/4 divided by 18. So let's first actually look at the 3/4 part of it, because not all of you have it memorized where 3/4 is equal to 75 hundredths. And what we can do here, anytime we need to convert a fraction to a decimal, is we can just convert or do what the fraction states, 3 divided by 4, like this, to get to 75 hundredths. So all we're doing right here is making sense of this in decimal form. 6 3/4. What does 3/4 mean? Well, it's 3 divided by 4, 3 divided by 4. 4 can't go into 3, so we're going to put a 0 here with a decimal point after it. And then we're going to place a 0 over here. Can 4 go into 30? Yes, it can. 7 times. 4 times 7 is 28. 30 minus 28 is 2. Can 4 go into 2? It cannot. We're going to bring a 0 down from the dividend and place it here. 4 can go into 20 5 times. We place that number where the quotient goes. 5 times 4 is 20. And if you were to get something that looks like a remainder here, you would just bring a 0 down from the dividend and keep asking yourself how many times 4 goes into that, and you would add your place value. Tens, hundreds, thousands, 10,000s, etc. But this proves to you that 3/4 is 75 hundredths. And now I'll use this information in my problem. I have 6 and 75 hundredths, 6 and 3/4. 3/4 is the same thing as 75 hundredths, so I can write it as 6 and 75 hundredths like this. I won't include the 0, but I will write 6 and 75 hundredths just like this. 6 and 75 hundredths divided by 18. This is the problem that I'm working on right now. So I can write this like 6 and 75 hundredths. I always like to include my label, feet. Divided by 18. So what we notice in this problem right away, as I erase this stuff up at the top, is that you have a number that's smaller being divided by a number that's greater. Right away I recognize 18 cannot go into this number. Conceptually I understand that my quotient has to be less than 1. So you have to keep asking yourself questions as you solve division. Things like, will my quotient be greater than 1? Will it be less than 1? Greater than 10? Less than 10? This is what true math thinkers do. They really ask themselves questions. And they don't make silly mistakes. They don't make silly mistakes as a result, because if you're a math thinker, you're trying to ask yourself questions to get to the right answer. So from here, 6 and 75 hundredths feet divided by 18, we're going to employ that convert to a whole number strategy, and we would move the decimal spot, in this case, 2 spaces to make 6 and 75 hundredths a whole number. Sometimes you have to move the decimal spot more than 2 spaces to make the decimal a whole number. Moving the decimal spot 1 space is like multiplying by 10. Moving it 2 spaces is like multiplying it by 100. Moving it 3 spaces is like multiplying it by 1,000. In this case, we'll also move the decimal 2 spaces, 18 but we're going to multiply, but you know, it's the same thing as multiplying by 100, so 18 times 100 is 1800, and if you want to see what that looks like, times 100, two spaces, 1, 2, two zeros would go there. So now we have this new problem, 675 divided by 18, or divided by 1800, and I'm going to erase all of this to show you, to have more space, and then we'll work on this problem. 675 divided by 1800. So like in the previous problem, what I do right away is I look at the problem in a slightly different way. I'm going to write 675 over 1800, or 675 1800ths. And I know one thing right away. I know, just by looking at this, it's neat because I can see if this is a fraction, I know the value, um, I know that 900 out of 1800 is half, but so something that's like 675 over 1800 is going to be less than half. That right away, that tells me that the people, when I divide this yarn up, they're going to get less than half a foot. So sometimes when you set the problem up like this, it's really neat. You get to see it in a different light. I know something else. This ends in a 5, this ends in a 0. Both of them are actually divisible by 5. And so I can make these numbers smaller. 675 divided by 5 is 135. And 1800 divided by 5 is 360. Now I'm working with smaller numbers. And I could divide these even further by 5 because I know that this ends in a 5. In fact, I'll do that with a calculator right now just to show you, just to prove to you. 135 divided by 5 is 27, okay? And 360 divided by 5 is 72. So really, this is, if you divide both by 5, this is 27 over 72. And what we can do now is we can divide 27 by 72, like this. Now we're working with numbers that are easier to manage. Okay, let's begin now. Can 72 go into 2? It cannot. We place a 0 above the 2 with a decimal point after it. Can 72 go into 27? No, it cannot, so we place another 0 in the area where the quotient goes. And now we still need to try to put 72 into this number, so we're going to place a 0 in the dividend area and ask ourselves, can 72 go into 270? It can. Well, I know that 70 times 4 is 280, so 4 will be too large, so I'm going to try 3. 72 times 3, let's try it here. 72 times 3 is 216. So 72 times 3 is 216. And then we are left with 54 once we subtract. Can 72 go into 554? It cannot. So we bring a 0 down from the dividend. 72 can go into 540. I know that 70 times 5 is 350. I know that 70 times 7 is 490. I know that 70 times 8 is 560. I think I'm going to try 7, 72 times 7. Because 70 times 8 would be 560, and that would be too large. So I'll try 72 times 7, and I get 7 times 2 is 14. Carry the 1, 47 times 7, 49, plus 1 is 50. I get 504. And watch, from here I can continue the problem. See? I mean, I could stop. 37 thousandths of a foot. Tenths, hundredths, thousandths. Okay, I could stop. I have two place values that are non-zero here. If I were to continue, watch what would happen. 540 minus 504 is 36. Now I have a choice to make. I could keep trying to put this number into this number and put my numbers up here in the quotient area. There are no more numbers to bring down. Okay? I could simply write this as my remainder, but it's not really going to be written as a remainder. I've got 36 as a remainder over 72, which is half. So I could put the 5 over there, like this. I personally actually just like to keep continuing, bringing the zeros down. 72 goes into 360. It actually goes in 5 times, and that's why that we have that 5 there. So this is how you would solve that type of problem, or how I solved it. And I'm encouraging you to think. What I did differently was thinking like this, writing your problem out like that. It lets you see it in a different way. All right, thanks. You can get to your work, and I'll see you later. Bye.